You're receiving this video because you have some points to recover on the Geometry B Unit 6 test. I'm going to go ahead and get started here very quickly, but I wanted to make sure you understand the instructions. Make sure to write down the question numbers from any questions you missed any points on the test, and then take detailed notes on each of the questions that you missed, writing down and drawing each picture and writing each step that I write down for the problems that you missed points on, and that will earn you back half your missed points. That's a significant boost. All right, without further ado, let's go ahead and get started on question number 1. Question number 1 asks, this polyhedron has blank edges, blank vertices, and blank faces. All right, so in order to answer this question, we need to know what an edge is, what a vertex is, and what a face is. Let's go ahead and copy the question here as well. Okay. An edge is a line, right? It's where the space where two walls or two faces meet, and it is always a line segment. So let me change colors here to blue. There is 1, 2, 3, 4, 5, 6. So 3 on top, 3 on bottom. 7, 8, 9 edges. So it looks like there are 9 edges. Edges are lines. Okay, vertices are corners. So let's choose a different color. How about pink here? Okay, corners are right here. 1, 2, 3, 4, 5, 6. Those are vertices, 6 vertices. And faces are flat surfaces. There's a front and a back, that's 2. There's a top, that's 3. There's a left, that's 4. There's a bottom, that's 5. So there are 5 faces. Or you can say there are 3 lateral faces and 2 base faces, 2 triangular faces. So there are 5 total. Okay, so that's question number 1. Question number 2. Let's go ahead and copy the question here. It's asking for the volume and surface area of this polyhedron, and then we just take the same shape we were given just now, and we are given dimensions on the polyhedron. Okay, so this is question number 2. Question number 2, question number 2. Volume and surface area. All right, so the volume can be thought of as the area of the base times the height. The base is this triangular shape, right, pulled through space. So there are 2 of them, right? And it's pulled through space. So the base is this triangle, and the triangle appears to be a right triangle, and we're going to take that assumption. So the area of the triangle, the area of the base, is 1/2 the base of the triangle times the height. The base of the triangle is 6, and the height of the triangle is 4. So the base, capital B, of the prism is 1/2 6 times 4. Half of 6 is 3. 3 times 4 is 12. 12 square centimeters. Okay, so the volume is the area of the base, 12 times the height. The height of the prism, the distance between the bases, is 3. 12 times 3 is 36 cubic inches. Okay, so that's the volume, 36 cubic inches. Okay, surface area is a little tougher. You can break this down into its components and find the area of this triangle and that triangle and this rectangle and this rectangle and this rectangle and add them. I'm going to use the formula given in the unit. Surface area is 2 bases. That's the front and the back, or the top and the bottom, however you look at it. Plus the perimeter, that's the distance all the way around the triangular base, times the height. Because if you take the perimeter times the height, if you take all the lateral edges and combine them together, cut them out and string them together, you get one big long rectangle. like so, whose height is the height of the prism and whose width is the perimeter. Okay, so that's the idea behind that. So let's go ahead and fill in what we know. The base, that's just 1/2 4 times 6, which we've already determined is 12, right? The perimeter is a little tougher. It's 4 plus 6 plus this length right here that we'll call x. Now we don't know x, but we do know a rule that relates the sides of a right triangle. 4 squared, the Pythagorean theorem says 4 squared plus 6 squared equals x squared, or x is the square root of 4 squared plus 6 squared. Okay? All right. So the perimeter is 4 plus 6 plus the square root of 4 squared plus 6 squared. All right. Now we can calculate that if we wanted to. 4 squared is 16, 6 squared is 36, 16 and 36 is 54, so this is root 54. Or we can leave it like that as well. Okay, but that's the perimeter. Okay, times the height. Okay, times the height. Perimeter times the height is the rest of the formula, and the height is 3. So let's go ahead and simplify this. 4 plus 6 is 10. Square root 4 squared plus 6 squared is square root 54. Okay, so that's the perimeter. So the surface area becomes 12, 2 times 12, 2 times the base, 2 times 12, plus the perimeter, 10 plus root 54. You need this parentheses because it's the whole perimeter, times the height, 3. Okay? And we're going to enter that in Desmos. Desmos, oh Desmos, you're the Desmos, not the Des least. Okay, get rid of that here. All right. So we're going to do 2 times 12 plus parentheses 10 plus square root 54. Get past the parentheses, times 3. Okay? And it looks like 76.045. 76.045. Okay? And I'm going to pause for a moment here because that's not exactly the answer on the key. Yeah, it's a good thing I paused and checked. The square root of 52 is this number, not 54. 4 squared is 16, 6 squared is 36, 36 and 16 is 52. And so this is 52. If you saw that before, I apologize. You were probably screaming at the camera saying, what? 52. All right? So it's good to check. All right, so plugging all that into Desmos, yields 75.6. 75.6 square units, or square inches squared. All right, there we go. That's question number 2. All right. Question number 3. Question number 3, we're given a cylinder, a right cylinder. Right cylinder just means a cylinder that stands straight up and doesn't lean over. Because you can have a cylinder that leans, in which case the volume is the same. Just make sure to calculate the height as the perpendicular height, but the surface area is definitely changed, and we're given no instructions to find the surface area of a non-right cylinder or prism. All right, so here we go. So we're going to find the volume and the surface area. First thing to note is that we're not given the radius. We're given the diameter. So the radius is 8 divided by 2, so the radius is 4. Okay? And let's grab the appropriate formula. The volume is pi r squared h, where r is 8 divided by 2, or 4 centimeters. And h is 2 centimeters. So the volume is pi r squared, 4 squared, h, which is 2. Okay, we can do this. 4 times 4 is 16 times 2 is 32, 32 pi. But we can round it because I think we were given, yeah, right, we were given instructions to round to the nearest tenth. So 32 pi, 32 pi, 32 pi is 100.5, and that does agree with the key. 100.5, and this is centimeters cubed. We're figuring out how many of these cubes, sugar cubes so to speak, fit inside, including partial ones. So that's volume. And then surface area, we have 2 circles and a rectangle, right? So the bases and the height and the perimeter, right? So the bases are circles with a radius of 4. So the surface area is 2 times pi r squared plus the circumference, 2 pi r, times the height, h. R is 4, h is 2, so the surface area is 2 pi times 4 squared plus 2 pi times 4 times 2. Okay, let's plug that into Desmos. Two pi times 4 squared plus 2 pi times 4 times 2, and we get 150.8. And that is approximate because we did round. 150.8 square centimeters. Surface area and volume. Okay, that's question number 3. Okay, question number 4. We have a pyramid. Now, one thing that caught a lot of people on this is the base is not a square. The base is a rectangle. And so the triangles on the sides are not the same. The front and the back triangle are the same. And the left and right triangles are the same as each other, but the front is not the same as the left or the right. Okay, so that's one area that led to missed calculations here. So this is question number 4. Okay, the volume is fairly straightforward. It is the area of the base times the height divided by 3, or times 1/3. In this case, the area of the base is 8 times 5, and the height is 5.5. So the volume is 1/3 times the area of the base, 8 times 5, yes. I thought I was thinking 8.5. That's what? That doesn't make sense. 1/3 of 8 times 5 times 5.5. Or you can think of it as length times width times height divided by 3. Okay, so we get 1/3 times 8 times 5 times 5.5. We get 73 1/3, or 73.3 cubic centimeters. Okay, and that's volume. Surface area is a little tougher. We got to break it down into its shapes. Okay, so it's one rectangle, that's 8 by 5, plus 2 triangles that are 8 by something, plus 2 more triangles that are 5 by something. You notice the base here of the right-hand triangle is 5, and the base of the left-hand triangle is 5. The base of the front triangle is 8, and the base of the back triangle is 8. There are different triangles. Okay, so we need to figure out their heights. All right, so let me change colors one more time here. Let's go with, let's go with pink. Okay, so one is to consult this right triangle right here. Okay, this right triangle. We start from the center and go to the edge along the left to right dimension, so this must be half of 8, or 8 divided by 2, or 4. By the Pythagorean theorem, then, this is 4 squared plus 5 squared square root. Okay? Or 16 plus 25 square root, or 30, 40, 41, square root 41. Okay? Then you've got this triangle right here. Let's see, let's go blue here, because we haven't done blue yet. We've got this right triangle right here. And it's kind of coming out of the page at us. And it's starting from the middle and going to the edge front and back. That's half of 5. 5 divided by 2 is 2.5. Okay? And so this must be square root of 2.5 squared plus 5.5 squared. And what I just realized something. I did 5 squared, and it should have been 5.5 squared. So I'm just going to leave that as is, 5.5 right there. Okay. 2.5 squared plus 5.5 squared, square root. Okay. All right, and that is the height of this triangle. So the height of this triangle with the 8 base is square root of 2.5 squared plus 5.5 squared. And the height of this triangle with a 5-inch base is square root 4 squared plus 5.5 squared. Okay? All right, and so the area of this is length times width. The area of this is 1/2 base times height. The area of this is 1/2 base times height. Different heights for both. So the surface area, let's see if I can write this out, is 8 times 5 plus 2 of these triangles that are 1/2 of 8 times square root 2.5 squared plus 5.5 squared, plus 2 of the 5 centimeter base triangles, 2 of the 1/2 times 5 times square root of 4 squared plus 5.5 squared, square root. So we got all of that. That's big and ugly, isn't it? Oogly. It's so ugly, it's oogly. All right, let's see what it looks like on the calculator here. See if we can enter this. All right. So 8 times 5 plus 2 times 1/2. Go ahead and get out from under the 2. 2 times 8 times square root 2.5 squared plus 5.5 squared. Get out from the parentheses there with the arrow key, plus 2 parentheses times 1/2, get out from the parentheses, times 5 times square root 4 squared plus 5.5 squared. Okay, and our answer is 122.3. 122.3. So approximately 122.3 cubic or square centimeters, because this is how many postage stamps can cover the surface. Okay, so surface area and volume. All right, that surface area was ugly, wasn't it? All right, next one, that's number 4. So next question is number 5. Numero 5, number 5. Ooh, we have a cone. I like cones, because you can put ice cream in cones. You can funnel your oil when you fill your car with a cone. It makes a great party hat, cone. Right? Lots of things can make cones. It makes a good roof for a silo. Okay, though those are usually hemispheres. All right, so here we go. So we've got a cone. Radius 4, height 7, and we want to find the volume and surface area. So volume is the same as a cylinder. It's pi r squared h but you divide by 3 or multiply by a third. That's it. So in this case, the radius is 4 and the height is 7. So volume is 1/3 pi times 4 squared times 7. Okay, calculate it. Calculate it, not calculus 7 it or calculus 6 it. You calculate it. All right, 1/3 pi times 4 squared. Whoops, squared. Shift 6 times, get out of that, times 7. And there we go. We got 117. 117.3. 117.3 cubic centimeters. Okay, then we're asked to find the surface area. Let's find the surface area. Formula for the surface area is the area of the circle, pi r squared, times the lateral area, which is pi r l, where L is the slant height. Another way to think of this is L is the square root of the radius squared plus the height squared. Because we're looking at this right triangle and we're using the Pythagorean theorem. Square root 4 squared plus 7 squared. That's the slant height. Okay, so we know the radius, we know the height. So the surface area is pi times 4 squared plus pi times 4 plus, not plus, square root, radius squared, 4 squared, plus height squared, 7 squared. All right. So surface area is approximately pi times 4 squared plus pi times 4 square root 4 squared plus 7 squared. And we have 151.6 cubic centimeters. Or no, square centimeters. The other one is cubic centimeters. So square centimeters for surface area, cubic centimeters for volume. Volume. Volume! All right. Yeah, sorry to frighten you there. All right. We're also asked to find the lateral area. The lateral area is just one small part of the surface area formula. The lateral area is right here. Pi r squared, pi r l. That's the lateral area. So the lateral area is pi r square root r squared plus h squared. So the lateral area is pi times 4 square root 4 squared plus 7 squared. The lateral area is approximately, let's find out. We can just take the first part and erase it. Boom. 101.3. 101.3 square centimeters. Okay, that would be the total area of the cone without its circular base, which would be like the area of the paper made in making a paper funnel for your oil in your car. Okay. All right, so that was question number. That was question number 5. Okay, so question number 6. We're given a sphere. A sphere of danger, yes. I think of the circus acts where they have a metal cage sphere and they ride a dirt bike in the sphere, going vertical and horizontal and all kinds of them running circles around the sphere. Really kind of fun to watch. All right. So number 6. Volume The formula for the volume of a sphere is 4/3 pi r cubed. Notice a couple things about this. Notice it has two threes, right? Because it's to the third power, it's three-dimensional, its volume. And it has no 2's at all. No 2's anywhere in the formula. Okay, as opposed to surface area, which I'll write down here, which is 4 pi r squared. Notice the 3's are gone, and the exponent is now a 2, right? No 3's at all. So just notice the similarities and differences, and that'll help you remember it. So volume is, R is 4, so volume is 4/3 pi times 4 cubed, 4 to the third power. So volume is approximately Desmos. Okay, and 4/3 pi times 4 to the third power. Okay, and we get 268.1. 268.1 cubic centimeters. Okay, surface area, 4 pi r squared. Surface area is 4 pi times 4 squared. Surface area is 4 pi times 4 squared. $201.1. 201.1 square centimeters, approximately. Okay, so that's the volume and surface area of a sphere. If it were a hemisphere, we'd simply divide all that by 2. Okay. This question here. This is based on an actual true story. There was a TV show in the 70s that portrayed an actor as a detective, right? And he wasn't a particularly big man. He was about normal height, but they wanted him to look big, so they actually made a 3/4 scale Lincoln Continental for him to drive. So Lincoln Continental's a big car. But they made it 3/4 scale so that when he got in and out of it, he would look bigger. Believe it or not. Now, I can imagine what it would take to do something like that, but that's a lot of work to make an actor look big. In order to make an actor look bigger on the screen, the studio decided to have a 3/4 scale Lincoln Continental made. The original car had a surface area of 580 square feet and weighed 470 pounds. The surface area of the scaled down car is, right? Now, the 3/4 scale means that it's 3/4 as long, right? The ratio of length, if this is 4 feet, then this is 3 feet, right? That's the idea. I'm not saying the cars are actually 4 feet and 3 feet, but that's the ratio of their lengths, 4 feet to 3 feet. So we can do this a couple of ways. We can do this way. 4 is to 3 is our scale factor, right? And actually, 3 is to 4. We want to do new to old. Scale factor is new divided by old. We're going from big to small. We're shrinking the car. So new is 3, old is 4. So the scale factor for the area is that squared, 3/4 squared. 3/4 squared is 9/16. So when we want to change the surface area, we're going to do 580, which is the surface area of the original car, times 9/16, or 9/16. So 580 times 9/16. 580 times 9/16. 326.25, or about 326.3. 326.3 square feet. Okay? So from 580, almost 400 square feet down to just a little over 300 square feet of surface area on the scaled down car. Now here, weight. Now weight isn't volume, but weight is associated with volume. If you have twice as much volume, you have twice as much weight, right? So if you carried 2 buckets of water, you'd be carrying twice as much weight as 1 bucket of water, and that's volume. So let's do volume. Now the ratio of volume, if the scale factor is 3/4, then the volume scale factor is going to be 3/4 to the 3rd power, which is 3 times 3 times 3, which is 27, over 4 times 4 times 4, which is 64. So 27/64. So notice now the ratio is well under half. It's like 40% or so, right? And the scaled down car is going to weigh less than half the original car. That's not something that's not intuitively natural, is it? So the original car was 4,700 pounds, about 2.5 tons, almost 2.5 tons, times 27/64. Let's use the same notation, 27/64. Okay, let's find out what that comes to. So 4,700 times 27/64. 1,983 feet, or 1,982.8. 1982.8. 1982.8 cubic feet. Okay? Or cubic feet. Pounds. Pounds. This isn't volume. This is weight. Pounds. So this smaller car is going to weigh less than a ton. A ton being 2,000 pounds. Okay. All right, so let's go now to question number, that was question number 7. So let's go to our final question. Question 8. Number 8 is a composite solid. It's made up of several solids. In this particular case, it is a reduction. It is a one solid subtracted from another. Okay? It's a cylinder with a hemisphere carved out of it. So that cylinder, it's like a mug or a bowl, right? With a spherical opening in it, right? Okay, and so we're to find the volume of the mug without the sphere carved out of it. The volume of the solid. All right. So the volume of the solid, just going to call it a solid because there's no other good name for it, is the volume of the cylinder minus the volume of the hemisphere. Okay, the volume of the solid is the volume of the cylinder minus the volume of the hemisphere. Okay, let's see if we can break that down. The volume of the cylinder, call that VC, is the cylinder is pi r squared h. R is 6 divided by 2, or 3. H is 3. So the volume of the cylinder is pi times 3 squared times h, 3. And I'm going to go ahead and simplify this. 3 times 3 is 9, times 3 is 27 pi. Don't have to. You can leave it pi 3 squared times 3 as well and just enter that in Desmos. Okay, that's the volume of the cylinder. The volume of the hemisphere is half of a circle, half of a sphere. So half, start with half. And the volume of a sphere is 4 thirds pi r cubed. We already know what r is. Okay, so the volume of the hemisphere is 1/2 times 4 thirds times pi times 3 cubed. Okay, let's go ahead and simplify that a little bit too. 4 divided by 2 is 2. Do a little cross reducing. Again, you can just leave all this and you enter it all in your calculator. And so 1 times 2 is 2. 1 times 3 is 3, so 2/3. Pi times 3 cubed is 27. And let's go ahead and simplify a little further. I can think of this as 27 over 1, cross reduce. 27 divided by 3 is 9. So 2 times 9 is 18 pi. Okay, so that's the volume of the hemisphere. So the volume of the solid then is the volume of the cylinder, 27 pi, minus the volume of the hemisphere, 18 pi. And those are like terms, so we can go ahead and subtract. 27 pi minus 8 pi is 9 pi. So the volume of the resulting cylinder is 9 pi. Interesting, by the way, the ratio of between these two is 2/3. Okay, so here we go. So 9 pi, approximate. 9 pi is 28.3. 28.3. Okay, and that's cubic centimeters. All right, now we're asked to find the surface area. So if I had to paint this or put glaze on it all the way around on all surfaces, got to think of what sizes, what shapes there are. There's the hemisphere. Plus there's the lateral side of the cylinder, which is the perimeter times the height. This is the radius. Plus there is the base, the bottom, with a radius of 3, which is a circle, pi r squared. So we've got those 3 areas here. The hemisphere is 4 pi r squared, but it's a hemisphere, it's half a sphere, so it's half of 4 pi r squared, plus the lateral area, which is the circumference of the circle, 2 pi r times the height, plus the base, the bottom, which is pi r squared. Okay, so we've got all of that. Surface area is 1/2 of 4 is 2. Pi times 3 squared plus 2 pi times 3 times the height, 3, plus pi times 3 squared. And I'm just feeling ornery right now. I'm not going to plug this all into my calculator. 3 squared is 9. 9 times 2 is 18. 3 times 3 is 9. Times 2 is 18. 3 squared is 9 times 2, 9 pi. So 18 and 18 is 36, and 9 is 45 pi. So the surface area comes to 45 pi, which is approximately 45 pi, 141.4 square centimeters. There's the surface area, and there's the volume. Considerably more surface area than volume. And that's because it's concave, so that's going to increase the surface area while decreasing the volume. All right, that is it. That's question number 8. So go ahead and send me your notes. Make sure you included all sketches and all work, all steps. And you can text it to me if you need to, but if you text it, make sure you include your name and what assignment this is, or you can webmail it to me as well.